He wasn't even supposed to find it. A signal, buried in noise, stronger than anything around it. And then, it was gone. In the summer of 1977, at a radio observatory in Ohio, astronomers weren't searching for aliens. They were listening for patterns. Every day, a massive radio telescope scanned the sky in silence, not capturing images, but something far stranger. Radio waves, invisible signals, constantly passing through Earth, coming from stars, galaxies, and places we still don't understand. Most of those signals meant nothing: static, background noise, random interference, the universe speaking but not saying anything. The telescope was called the Big Ear. It didn't move like a typical dish. It stayed fixed as the Earth rotated beneath it, which meant the sky slowly drifted overhead, and anything out there would pass through its field of view naturally for about 72 seconds. No more, no less. Days later, all that data was printed onto paper, rows of numbers and letters, each one representing the strength of a signal at a specific moment in time. No visuals, no sound, just code. And that's where he comes in. Jerry R. Ehman, a quiet astronomer, going through stacks of data by hand, line by line, signal by signal, most of it forgettable, until it wasn't. Somewhere in the middle of one page, something stopped him. Not because it looked dramatic, but because it didn't fit. 6 E Q U J 5. To anyone else, it would mean nothing. But to him, it stood out immediately, because those characters weren't random. They represented intensity. In this system, numbers and letters were used to show how strong a signal was. Most signals barely registered. A 1, maybe a 2. Something slightly stronger might reach a 5. Rarely higher. But this kept climbing. 6, then E, then Q, then U, then J, peaking before dropping back down to 5. A perfect rise, a perfect fall. Exactly what you would expect if a signal passed directly through the telescope's field of view. Natural signals don't usually behave like that. They fluctuate, they drift, they break apart. This one didn't. It was clean, focused, intentional, almost. He stared at it, then read it again. 6 E Q U J 5. Then he circled it and wrote one word beside it. Wow. That note still exists today, a single reaction to something no one could explain. The signal lasted 72 seconds, exactly as long as the telescope would have been able to observe it. Then it vanished, completely. No fade out, no distortion, just gone. At first, it didn't seem like a big deal. Strange signals happen. Interference is common. Equipment glitches are expected. But this was different, because when they looked closer, everything about it became harder to explain. The signal came from the direction of the constellation Sagittarius, a dense region of the sky, filled with stars, not empty space, not nearby, deep, distant, crowded. But location alone wasn't the problem. The frequency was. For decades, scientists had quietly agreed on something. If there were other intelligent civilizations out there, and they wanted to be found, they might choose a very specific frequency to transmit on. A universal frequency, one that any advanced species would recognize. That frequency is tied to hydrogen, the simplest and most abundant element in the universe. Hydrogen emits radiation at a very precise wavelength, a kind of natural marker, a cosmic reference point. If you were trying to say, "We exist," to something across the galaxy, that's where you'd start. And that's exactly where this signal appeared. Not close to it, not near it, exactly on it. Which made the situation uncomfortable. Because now the question wasn't just, what is this? It became, who or what would use that frequency? So they began eliminating possibilities. Could it have been a satellite? In 1977, there were far fewer satellites than today, and none were known to transmit at that frequency. None matched the position. None matched the strength. Could it have been interference from Earth? Unlikely. The signal was too precise, too isolated. It didn't bleed into nearby frequencies. It didn't behave like noise. It behaved like a signal. A natural source, then? Maybe. Stars, pulsars, quasars. They all emit radio waves, but they don't usually spike like that. They don't rise and fall so cleanly, and they definitely don't appear once and never again. Everything they tested almost worked, but not completely. So they did the obvious thing. They tried to find it again. They pointed the telescope back to the exact same location, waited for the sky to rotate into position, and listened. Nothing. They tried again. Nothing. Days passed, then weeks, then months. Still nothing. Other astronomers got involved. Other observatories joined the search. More advanced equipment, more sensitive receivers. If the signal came back, they would catch it. It didn't. Years went by. Technology improved, search methods evolved. Still nothing. No repeat, no confirmation, no second chance. Just one moment, one detection, one line of data, and silence. Eventually, new theories began to form. One of the most widely accepted explanations was that the signal came from a cloud of hydrogen gas, a natural source, something ordinary, something safe. But there's a problem. Hydrogen clouds don't behave like that. They don't produce signals that spike so sharply, then disappear completely. They don't match the pattern that was recorded, and they don't explain why it only happened once. Because even if the source moved or changed, you would expect something, a trace, a repeat, an echo. There was nothing. And that's what makes this different. Not just that we don't know what it was, but that we had one chance to observe it, and it slipped past us. By the time anyone realized what they were looking at, it was already gone, which leaves us with something difficult to ignore. A signal, detected once, by accident, from somewhere in deep space, perfectly aligned with the one frequency we thought someone might use if they wanted to be heard. And then, silence. No follow-up, no message, no explanation. Just a question that has been sitting there for decades. Was it natural, or was it something else? We don't know, and that might be the most unsettling part. Because if it was just a random cosmic event, then it's an extraordinary coincidence. But if it wasn't, then it means something out there sent a signal, and we missed it. Not because we weren't listening, but because we didn't recognize it in time. We saw it, after it had already passed, like catching the last second of a conversation, without knowing who was speaking, or why. And now, there's no way to ask, no way to respond, no way to know if it will ever happen again. We were listening. Something answered, and we never heard it again.